classic Shakespearean play that we have all encountered at least once in our academic career. The story of two star-crossed lovers fated for death and loving each other despite their family conflict. Nevertheless, love like that is rare to find, so we will delve into more realistic relationship scenarios. In this scenario, Romeo and Juliet's relationship reflects the relationships from Victorian era all the way till now. This scenario is especially evident in modern relationship dynamics in which romance lies in the chase. As a result of the chase, there will always be one who enjoys it more than the other one, and the other who gets hurt. Would you believe me if I told you that this dynamic could be discussed through modeling differential equations and phase portraits? Yes, you heard that right. We can model your relationship. We will explore these predictions by cases. Case 1, unrequited love, where Romeo loves Juliet, but Juliet doesn't love Romeo. Then we have case 2, which is head over heels. This is where both of them love each other, a happy relationship. And then case 3 is mutual disdain, where both characters are tired of playing games and inevitably hate each other. If Romeo and Juliet were to be diagnosed in terms of case 1, one would say that Juliet experiences the grass is greener effect, while Romeo experiences the harsh realities of unrequited love. The more Romeo expresses his love towards Juliet, the more she runs away. Interestingly, when Romeo is intimidated by Juliet's lack of emotion, Juliet starts to be suddenly attracted to him. As a result, Juliet is a volatile variable, as stated in the SIMIODE article. This might be caused by the fear of a real relationship and in not living up to her expectations. Therefore, when Romeo is interested in her, she's able to fantasize a fake relationship, but when he likes her, it becomes too real. Romeo, in comparison, desires Juliet when she shows interest in him and becomes disinterested when Juliet no longer gives him attention. Now, let's explore this mathematically.
Alright, hello everybody. My name is Marinaccio, and myself and my group mates are presenting a project involving systems of linear differential equations entitled Heartthrob and Heartbreak, a mathematical analysis of Romeo and Juliet. And the authors are Katherine, Briganti, Mariami, Osepaishvili, Melissa Feliciano, Santiago Santos, and myself, Noah Marinaccio.
Case number 1, unrequited love. In this case, we have a system of differential equations. dr over dt equals aj, dj over dt equals negative dr, and a set of initial conditions r0 equals 0, j0 equals 2, a equals 1, and b equals 1. From this, we can say, based off of the initial value problem, that the relationship in this case is inversely proportional. This is due to the sign difference between the two coefficients of a and r. We solved both of them independently using separation of variables. We got j and r as functions of time. To observe the basic relationship dynamics graphically, we will plot r of t and j of t as functions of time. In case 1, we have r denoted as y and j denoted as x, and we use the slider to change the value of time, which is shown as t and c. Using this software, we were able to plot the phase portrait, and these are the results. And from the results, we can see that Romeo's and Juliet's feelings are moving away from each other. Alright, this is the discussion of the results of case 1. Noted earlier and seen in the plots, there is a sign difference between the coefficients a and b. This is due with hate being associated with negative values and love being associated with positive values. This is what causes the relationship dynamics between Romeo and Juliet to be inversely proportional over time t. Graphically, we see that the linear slopes represent the rate at which hate or love increases in the given scenario. Therefore, if we increase the coefficients, we can increase the rate at which love or hate increases. The more Romeo chases Juliet, the more Juliet hates Romeo, and vice versa. It can also be noted that when the curves intersect, Juliet's hate and Romeo's love are equally as strong as the other, thus balancing out with that other out.
Okay, so the next case we're going to talk about is case number 2, which is head over heels. And for this case, we have a very similar model of a system of differential equations, the only difference being the sign of a and b are both positive, which basically means we're going to set two sets of initial conditions, R of 0 equals 4, J of 0 equals -2. We'll call this scenario number 1. And R of 0 equals 1 and J of 0 equals 2, which we'll call scenario 2. And we'll be able to model both of these as plots in our graph, and we'll be able to see exactly what's going on. So we see here we used a very similar technique as case number 1. We solved both of these equations using separations of variables. And scenario number 1 yields R as a function of time, jt plus 4, and j as a function of time as rt minus 2. And scenario number 2 yields similar results with R of t equaling j of t plus 1, and j equals rt plus 2. And now we can plot these solutions as functions of time, similar to how we did in case number 2. So we see here, as we adjust the slider, the graph on both of these lines are going to end up being positive. What this means is that both Romeo's feelings and Juliet's feelings are going to trend towards love, because both of these coefficients are positive, and there's going to be two positive slopes when we graph the solutions to these equations. And we see similar results here as we keep adjusting the slider. Another interesting thing to note is that where the graph intersects the axis is basically where it starts. So Juliet could start off hating Romeo, but she can still trend towards love, while Romeo can always love Juliet and trend even further towards love. Discussion of the results for this case. The variation of the model is called head over heels because Romeo and Juliet both will trend towards love, and this is due to the coefficients A and B both being positive. And this results in a positive rate of change for love. Love is increasing positively. Furthermore, we introduced two sets of initial conditions. Scenario number 1 has Juliet trend towards love while starting out hating Romeo, meaning that her feelings change over time. And scenario number 2 has both of them starting out loving each other. This distinction is seen in the sign of the y-intercepts of the solutions, since the solutions are given in the form of y equals mx plus b.
So in case 3, we call mutual disdain because in this case, we will see what happens when Romeo and Juliet's feelings for each other both trend towards hatred, with Romeo starting off with love. So we solve this system independently using the separation of variables method. So we see in both equations that the coefficients are negative, which represents their hatred for each other. And we can also see that Romeo started off with love because the y-intercept is positive. As we can see the equations plotted here, as time increases, the slope representing their hatred, which are both negative, increases, which ultimately means that as time continues, Romeo and Juliet's hatred for each other increases. So for case 3, we see according to the model that Romeo starts off loving Juliet due to the positive y-intercept, but trends towards hating her as Juliet begins to hate him. Both of the solutions have negative slopes, resulting in negative rates of hate.
In order to generalize this model and call it cautious lovers, we can get this kind of system of differential equations,
where Romeo's feelings depend on both his own and Juliet's feelings, and similarly Juliet's feelings depend on her own and Romeo's feelings. So from here we can see that the values of A and C will show whether Romeo's feelings will trend towards love or hatred, and the values of B and D will show the initial feeling of love or hate of Juliet.
As we mentioned, our generalized system looks like this, where if we choose the coefficients to be A equals D equals -1 and B equals C equals 0.5, we get this kind of system, which can be written in matrix form. So in this case, our x prime is this, and x will be this. First, to solve this system, we have to find eigenvalue of the A, which can be done using this formula. Lambda squared minus trace of A times lambda plus determinant of A equals to 0, where our eigenvalue is denoted as lambda. Trace can be found by adding these numbers. So trace of A will be -1, which will give us -2. And determinant of A can be found as -1 times -1 minus 0.5 times 0.5, which will give us 0.75. So from these values, we can create this quadratic equation. So we have -2 lambda plus 0.75 equals to 0. And now we get lambda squared plus 2 lambda plus 0.75 equals to 0. And then we are going to solve this quadratic equation. So where we will get two distinct values for lambda. Now that we got our eigenvalues, we have to find eigenvectors, denoted as B, and we are going to be using this formula, A minus lambda I times this B vector equals to 0 vector, where I is an identity matrix and can be expressed as we have to find eigenvectors for each of the eigenvalues minus lambda, because lambda times 1, then we don't have anything for this one, same as this, and then -1 minus lambda. E1, E2, if we plug in lambda 1, we get this.
Similarly, for lambda 2, we get the following.
Now that we got these results, we can use the software to plot the face portraits.
Using the software, this is the result that we got for face portraits, and this is what it looks like.
We see from our study of Romeo and Juliet's relationship dynamics that even abstract human emotions such as love can be modeled mathematically using systems of ordinary differential equations. When we solve the equations analytically and plot the solutions, it gives us a better understanding of how the relationship behaves. This is dependent on the sign of the y-intercept and the slope. When we generalized the model, we were able to use face portraits and graphs to view the trajectory of the relationship between Romeo and Juliet, and further understand how it depends on the love and hate Romeo and Juliet feel towards one another. We conclude that while human relationships can be difficult to quantify due to their unpredictability, we can also use mathematical methods to put together a general model of the relationships that work for many different cases and parameters.
Thank you.